In this video, we'll be discussing average rate of change. For a linear function, slope can be interpreted as the rate of change of the dependent variable per unit of change of the independent variable, x being our independent variable, y being our dependent variable. For a nonlinear function, which is anything that isn't a line, the average rate of change between any 2 points is the slope of the line containing the 2 points. This line is called the secant line. So we've got this curve here that's clearly not a line. If I want to find the average rate of change between the 2 points, A, f of A, and B, f of B, we want to find the slope of the secant line, which is the line containing these two lines. Although our points are written in function notation, a f of a and b f of b, opposed to x1, y1, and x2, y2, the way that we find slope is not different. The slope of this line is still the change in y divided by the change in x. So our average rate of change formula is essentially just our slope formula. y2 minus y1 over x2 minus x1. It's just our points are written in function notation instead. So the average rate of change is f of b minus f of a over b minus a. But honestly, all I think of is my normal slope formula, and I don't get caught up in the function notation. In order to find average rate of change, you have to have two x values and two y values. So let's find the average rate of change of the function from a to b. And these are simply our x values. A is our x1 and b is our x2. We have f of x equals 6x, and we're going from an a value of 0 to a b value of 4. Well, they've given us the two x values. x1 is equal to 0 and x2 is equal to 4. What we don't have at this point are y values. We have to find the y values. And the way that we do that is by simply plugging the x values into the given function. So I'm going to label it this way. y1 is going to be f of 0. So that's going to be 6 times 0, which is 0. And then our second y value is going to be what we get when we plug our second x value into the function. So that's going to be f of 4. So that's 6 times 4 equals 24. Now I have two x values and two y values, and I'm going to plug it into the slope formula. You may feel more comfortable by actually writing two ordered pairs, x1 comma y1 and x2 comma y2, and now we're just back to finding the slope of two given points. Rather than writing m, though, I am going to write average rate of change. Calling it slope is not correct since it's not necessarily a line. So we're going to have 24 minus 0 over 4 minus 0. This gives us 6. This gives us 24 over 4, which is equal to 6. So the average rate of change of our function f of x equals 6x between a equals 0 and b equals 4 is equal to 6. I do want to point out that this given f of x is linear. Y equals 6x is a line, so it's not surprising that our average rate of change ended up to be the slope of that line. Let's look at one that's definitely not linear. Our function f of x equals x squared minus 2x, and we want to find the average rate of change from a equals 3 to b equals 6. Well, we've got our two x values. All right, x1 is equal to 3 and x2 is equal to 6. Now we need to find the corresponding y values. We'll do that by plugging the x values into our function. So for y1, we're looking for f of 3. 3 squared minus 2 times 3. It's going to be 9 minus 6, which gives us 3. And then our second y value, we'll find that by plugging the second x value into our function. So that's f of 6 equals 6 squared minus 2 times 6. It's going to be 36 minus 12, which is 24. That gives us our second y value. We're going to find the slope between the 2 points, 3, 3, and 624. Our average rate of change, I'm going to abbreviate it this time, is equal to 24 minus 3 over 6 minus 3. That's going to give us 21 over 3. The average rate of change of the function x squared minus 2x between a equals 3 and b equals 6 is going to be 7.